Alright, time for another DraftPhysics.com video presentation. So, still on the lever experiment, but I still am interested in the connected oscillator thing. And so, I mostly played with that today. So I have some video of that, and we'll get to that. But I just wanted to play some of this original conversation with physicist Michael on the lever experiment, just to demonstrate that so far so bad for his claims. Okay, so his model has failed the first test. So in the first test, I mean, it's pretty clear, okay, in what I have shown of the lever experiment. So just like he's claiming a partial victory with his lever experiment, I will claim the counter victory. Okay, just making it clear that his prediction was completely wrong. Now, the first prediction he said was that levers don't oscillate. So if I put a 5 mass out here and a 10 mass here, it won't oscillate. And yes, of course it does. I proved that a long time ago. He was wrong. Okay. Second, he says, okay, that if I have this lever, he's saying this, it can't have opposite directions, right? Something can't go in this way and there can't conserve the momentum if it comes out this way. So in a sense, he's saying a Newton's cradle can't conserve the momentum because, frankly, one object is technically falling down and the next object is leaving, going up. So technically, the momentum's in the opposite direction. Now, we know that doesn't make any difference because the momentum is going to turn around because of gravity and come right back. So we know that's all garbage, but whatever, go ahead. Let them go ahead and talk their nonsense and get away with it without you doing anything to stop them, right? So the idea is you have the same mass, the same distance from the fulcrum, and his argument was when this object comes in, this can only leave with 1/2 the velocity. So this has a velocity coming in of 1, let's say, 1 velocity. This can't be more than 1/2 that velocity. That was his claim. Now, clearly, from the videos I showed you the other day, this is clearly moving faster than that. Okay, faster than half the speed. It's very close to the same speed. So it's whatever, 85% of the original speed that this came in, this one leaves. All right, that's undisputable, I think. I don't think anybody rational would say that isn't what was demonstrated. So clearly his math failed. Okay, so his mathematical analysis and prediction failed. Dismally failed. Just pointing it out. It failed. His model failed. His model failed. His model failed. Okay. Just sad that this is what the argument comes to. But let's play the video just to be sure you hear the failure and such.
To how you're doing it is we have to do it with a 2 mass and a 2 mass. Okay, we have to do it with a 1/2 mass and a 1/2 mass. We have to first prove the lever conserves the momentum when the energies are the same.
So here's going to be, I think, a bit of a sticking point, because again, my model does not predict that if you have a 1 mass and a 1 mass at equal distances, it's not going to launch it in that same way. And let me kind of explain why. If we go to M1 equals, let's say M1 equals 1 is the same as R1 is the same as M2, everything is just going to be 1 in this equation. Okay? And we're also going to assume that this moment of inertia, it's small. We're going to say that the bar is very, very small. If I take these two equations as conservation of angular momentum idea, we're going to get everything here. The only thing that's not 1 is just that initial velocity of object 1. And that has to equal this whole equation. M1 is 1, R1 is 1, so we get V1 final. M2 is 1, R2 is 1, we get V2 final. And when we identify that, okay, 1 mass stuck on one side, they're at the same distances, so V1 final, if this thing is rotating and they're at the same distance, whatever V1 final is, that has to be the same as V2 final. Which means I can take this.
So clearly that's not what happens. Okay, V1 stops entirely. So V1 final is 0, almost. Tiny reflection. Tiny, if any. And V2 is essentially V1's velocity. accounting for the losses of having to move the lever. So yes, it's only 85% rather than 100%. But clearly the idea is that V1 gives all of its energy to V2. Clearly the idealized lever will function that way. Clearly his math is wrong.
And say V1 final is the same as V2 final, so that's 2 V2 final. So the velocity of object 2 at the end is going to be half the velocity that the original object had.
So proven not to be true. So the prediction completely fails. The mathematics doesn't reveal the truth. It projects a lie, a falsehood, a fakery, a nonsense. It doesn't get the right answer. It's not a good model. It failed the test.
All right, well, I'm just going to say, okay, I've done part of this experiment by oscillating a lever, and clearly there's no indication that there's any difficulty in this lever oscillating perfectly. And it couldn't oscillate perfectly if there was half energy being created somewhere, or only half the momentum was being conserved. It has to be conserving all of the momentum.
Again, I disagree because we've got that fulcrum point.
Okay, so it's a nonsense point, frankly. I pointed out it's a nonsense. The fulcrum isn't absorbing any of the energy. Levers work because fulcrums don't absorb the energy. Obviously, if the fulcrum moves, then yeah, your lever's not going to work as well. Fulcrum doesn't move, your lever works really well. Just a fact. So yes, if something absorbs energy, then you're not going to get the energy back. Come on, that's not complicated, but whatever. All right, just rubbing it in because that's at the stage we're at, and so he deserves it, so I'll do it. I mean, they're claiming victory, so I just want to point out that this is the reality of their victory. They won't concede anything. And he hasn't made a video saying, oh yeah, I saw your video, you're right, gee, my math failed. He didn't make that video. My model fails. Didn't make that video. All right. And I'm just saying, I don't think he has a counter argument. I don't think he could deny the experiment. It's a pretty simple experiment. One thing goes in, the other thing comes out. Not very complicated. No springs in the way. No bullshit. You know. So, just saying. All right, now to today's mush.